Hey guys, welcome to the construction site on Saturday. Today we are going to attempt to do some thermal isolation on our foundation using XPS extruded polystyrene. You can see we got a new electrical box. It's not yet... Whoa! I just sank. The box is not yet connected to mains power, but the guys put it here in place. They're going to do a installation under the road in December, so we're gonna get nice electrical power here. I have been working on Thursday last week with some bitumen mass to bridge the gap between the foundation and the white isolation on the walls, and as you can tell, it came out pretty well. I'm hoping this will not peel off at all, but that's not a problem, because today we're going to apply some panels onto this that are going to basically be somewhere up to here with this polystyrene. And yeah, so the idea is to cover up the gap between the wall and the foundation, so if any water is in here it won't seep under the wall or wherever. But yeah, you can see all of this around here is done. And after the first wall, the north side, I realized that I'm not gonna have enough with one bucket of bitumen, so I made the overlap smaller. And basically the north side is the worst because that gets the least amount of sun, so if there's going to be some water issues, it's gonna be on that side. So I made sure that it's done very well. Here is the overlap is not that big, maybe 5 centimeters, but it's enough because I really just wanted to get the gap covered. So alright guys, let's unbox some of this polystyrene. Let's have a crack inside the box. Alrighty. So this is basically polystyrene panel. So this is XPS. There's different types of polystyrene. The technology, the process that makes it is different. This is extruded polystyrene, XPS with an X. And there's EPS, which is expanded polystyrene, which is basically a mix or like a clumping up of little polystyrene balls. This is supposed to be closed cell extruded stuff, so it's more waterproof. And I think this can absorb up to 1% water, whereas expanded polystyrene, I think 7 or something percent. And of course, the more wet this stuff gets, the less thermal isolation it offers. And in the EPS, between the little balls of styrofoam, you can see the channels can form where water can seep in and stuff like that. And this is much more resistant to that. But in general, this is really good for isolating foundations that are bound to be in a water environment like ours. So yeah, let's go have a test fit and see how this fits. Alright guys, so our polystyrene panel has a little cutout for an overlap. That way the panels go on top of each other and prevent like water coming through and heat seeping out. So it's like it's better than having just straight panels theoretically. And these will go onto the wall like this, and straight away I can see we might have some problems with this stuff that is poking out the tar paper basically, and then the wall there was like a little gap here, so we might have to cut a groove in the polystyrene. And this over here, yeah, I think we could take off the edge on the bottom here a little bit, cut off the edge here, and then cut a groove in here. So to do that, we're going to use some heated up wire, and we have to set up a jig for that. Alright guys, so I have a little persuading to do on my galvanized bar for our lightning protection, but since it's galvanized, I don't want to destroy the galvanized coating by striking it with a hammer. So I have a plan. My plan includes putting some painter's tape at the end of the hammer, such that when I strike there's no steel to steel contact, and maybe the galvanized finish doesn't get ruined. Let's see how this will work. I'm going to apply some layers to it just to soften the blow a little bit, or maybe not mar the finish. Let's give it a try. Yeah, like this. I got a little bracket and some screws. I'm gonna try to attach it maybe somewhere around here. Let's see how far the polystyrene goes up. The panel sits like this, and this should be fine. And then we can have a box below it, or maybe up here. But yeah, that will come with time. For now, let's just attach this so when I apply the polystyrene it's not in the way. So I took a trip to the building supply store in hopes they would have some system like brackets for mounting this, but all I came back with are these little galvanized plates, like generic steel galvanized plate, and then some little screws. So I don't know, this might be temporary or it might stay forever, but the idea is just to attach it to the wall so it stays upright, and then the electrical guys can get access to it and do whatever they need to do with it. So some people just drill through the bar, the steel bar, and attach it with the screws to the wall, but I heard that that reduces the ability to conduct electricity, so I'm just going to mount the plate like this and screw it into the wall. And that's it. And unfortunately I don't have any hammer drill with me, which is a big oversight because I thought I had it here. So I got my trusty old Makita. Let's see if it can drill through clay blocks, and yeah, this will be a first. So I'll put it in drill mode, second speed, no hammer function. Okay, that fits nicely. We'll just center this and make it. There we go. It's not going anywhere. And this galvanized stuff, it should resist the weather. I'm happy with this. We'll have to make a little cutout in the XPS, a groove for this bar, but that's also doable. Of course you could screw this in more places, but I don't want to damage the hydroisolation, maybe poking holes in it, so I'm leaving it as it is. So yeah, this should be pretty good. Alright guys, so you can cut styrofoam using different methods. You can use an X-Acto blade, which is not the best. I tried cutting this stuff, it's pretty hard. You need a really sharp blade and they dull quickly. Another way is to use a handsaw, but I think the quickest and best is to use a hot wire. And now we're going to do some engineering. To get a wire hot, you pass from electricity through it. Direct current is, I think, better. I don't know if there's a big difference, but I tried to use this battery charger with no luck. So I reverted back to my welder. The welding machine is basically constant voltage. It's a direct current DC. So it's very nice for heating up wires. So I hooked this up a piece of wire across here, one of those tie wires we use for rebar, and basically set my machine to 20 amps. Basically, if you touch it, it doesn't go, right? But if this wire heats up, you can see it's starting to smoke because of the previous attempts I did with XPS. Then you can just snap it. Oh, it gets really hot really fast. So I think some fine tuning is required. 20 amps is a bit too much, I'm guessing. More like 15 maybe. Yeah, this is nice. Cuts really good. No problem. So I'm going to build myself a few jigs with this wire. Basically a corner jig to cut off the bottom corners really fast, and then like a groove jig to cut out the groove for the part where the wall meets the foundation. There's like a bump. So for my corner jig, I'm just going to use 2 pieces of board. Doesn't have to be anything extreme, I just want a jig for holding the wire. Hack it together and go. That's really silly, but this is more or less together. This is for holding the wire. Okay, we wanted to cut off this piece, and yeah, I think this will be just fine. Alright, let's give it a try. Let's see if we can get this cut. Working. You can see the wires heating up really badly. This is going very slowly. Alright guys, so I built a second contraption. It looks like a music instrument. So I figured out that the thermal mass of the wire when it's running at a diagonal is too small, because it starts pretty fast and then it slows down and has to heat up before it can continue. So I took a piece of thicker wire I found in my grandpa's stuff. It's much thicker diameter, and I run it lengthwise so that it heats up, holds the heat, cuts the styrofoam and doesn't cool down as fast. Unfortunately, this has some galvanized coating, so you have to burn it off. And galvanized is toxic, don't inhale the stuff or you can die. Fair warning, okay? You've been warned, don't die, I warned you, okay? So first things first, we burn the galvanization away using our fantastic little welding machine. So the clamps, they go on both sides. So the power goes on. When it turns green and bubbles, don't inhale the stuff, okay? Like now. Alright, I think this is enough. You can see the wire got extended pretty loose. We should tighten it now while it's still warm. It turned green a little bit, smoked a bit. This should be fine now, I hope. This is super cool. It's still cutting, I turned the power off. So it has a lot of thermal capacity. That's really good. And nice. It's time to test the machine out. Let's not put it at full power, maybe 45 amps. Then let's preheat a little bit. This is good. Okay, it's working already. Let's see. Okay, pretty good. Alrighty, so before we start applying any of this, we gotta dust the surfaces off. Yeah, so that's done for dusting. I'm gonna dust the whole thing, but for now I want to show you this spray foam adhesive I got. This is like any foam can. You need a special applicator or pistol for it. I bought a box of these. They gave me their brand named one free. So it has a little tiny plastic nozzle to fill in the gaps later on. Actually it has two. That's very nice. So that will stay in the box. It has a knob here that you can tighten and loosen or change the flow of the stream. It has some pressure inside it from the factory. That's yeah, and these you gotta shake for 30 seconds before you can start using them. Also, it's best if you keep them warm. I've been keeping mine in the summer house, the container. You got a little heater there, it's about 20 degrees. Then you get the best 20 degrees Celsius. Then you get the best output of the foam. So none of it is wasted. Alright, let's give this a turn. I heard it squish, and we can spray some on the ground. Okay, that's really nice. So generally you want to apply this like this. So you're gonna apply this all the way around your thing. I think I need to regulate this better. Outwards. I think I have the pressure set too high. Let's try this. Yeah, this is much better. There you go. So the idea with going all the way around is that these will lock basically the water from getting behind the boards. Alright, I think I got a hang of it now. You can watch me learn. I didn't say I'm an expert. Let's go see what will happen when I try to push it against the foundation. This is where it's supposed to go. Build it to the side. Even with this edge, so that the overlap is nice. I got a little level here to get started out square. Let's see this. It's level 2. Right. Let's try this one for size. This should hold. Let's leave it like this for a while and let me get on to making the other ones. the burning, it's the wires getting thin on the bend because I keep bending it. I'll have to replace the wire now. Okay guys, on the last panel of the polystyrene, and we have to add some supports to push it to the wall. This way it's being constantly pushed. Alright guys, I made 3 boxes of polystyrene from a single can of glue. My battery is running out, so I'll catch you next time. Thanks for watching, and I'll see you soon. Bye.